Okay, today we're going to talk about water in our atmosphere. So the movement of water between the atmosphere and Earth's surface, this should be apostrophe S, Earth's surface, is called the water cycle. So you're going to write the water cycle on your page. And this is when the water has a cyclic motion from the surface back into the atmosphere. It's going to precipitate, it's going to run off, it might even go into groundwater, it's going to evaporate, and it's going to condense into clouds. And then this process is going to continue. Evaporation is the process by which water molecules in liquid water gain enough energy to escape into the air as water vapor. This technically is not a picture of evaporation, it's actually condensation because you can't see evaporated water vapor. This is just water that was in the air that is condensed over a lake, but it's very difficult to get a picture of evaporation if it's invisible. Humidity is the amount of water that's in the air. Hot days hold a lot more humidity than cold days do, so we're going to have more humidity in the summertime. It's a measure of the amount of water vapor in the air. How much water vapor is evaporated into the air. Relative humidity is how much water vapor is evaporated into the air compared to how much the air can hold. So for instance, if this is a summer day, it's going to be able to hold a whole lot of air. Almost, let's say all the air can hold water. Relative to how much the air can hold, how much humidity is there? So you could have, let's say that this entire picture represents air, and 100% would be the very top of the picture. If you had this much water in the air, right about here, you would have about 50% relative to the entire picture, relative to the entire atmosphere. On cold days, the atmosphere might be as big as the picture, but the air can only hold this much, about half of the picture, because cold air only holds less humidity than warm air does. And so if we have this much that can hold air, right here, and let's say that we have, now this whole picture is 100%, that's the atmosphere. But on a cold day, only this much can the atmosphere hold water. So if there's this much, then we have 50% relative humidity. Sorry guys, I'm trying to write with my mouse here. Okay, so we have 50% relative humidity compared to how much the air can hold. Now, if you think of the entire atmosphere, we only have 25% absolute humidity. There's only 25% water in the entire atmosphere. But the relative humidity is compared to how much the air can hold, how much water do you have? And in this case, it's 50%. So temperature affects humidity because warm air holds more water vapor than cold air does. Because the molecules are moving faster around, they're not condensed together, they don't fall out of the air, the warm air can hold more water. So why do you feel so hot on a humid day? Because evaporation slows down and has less cooling effect on your body. So you can see that these people are sweating, but the sweat's not going anywhere because the air is already saturated with water. And remember, the word saturated means full. So air is already full of water. These people are sweating. There's nowhere for the sweat to go. So you feel hotter on a humid day because you're not having that cooling effect. So last thing we're going to talk about is how clouds form. And this is condensed water vapor. And these things are heavy, very heavy. And you've watched a video on why clouds actually stay up in the sky. Clouds form when water vapor in the air cools off as it rises in the atmosphere and condenses to become liquid water, or if they're high enough up in our atmosphere, they become ice crystals. The dew point is the temperature at which the water vapor turns back into liquid water. This water was actually in the air, and when the air cooled, it cooled on this leaf, and that can happen on your car, it can happen on your windows, it can happen on your house. It just needs water vapor, needs a place, it needs something to condense on, and so this actually condensed on a leaf. This is not a picture of transpiration. This water did not come out of the leaf. Transpiration occurs when as a byproduct of photosynthesis. This just happened as the water in the atmosphere cooled off and it just condensed on the leaf. So water condenses on particles like salt, dust, and smoke. These are lenticular clouds. Clouds just can't form out of nowhere. They have to have a seed to form on. And so it'll form on salt, it'll form on pollution, it'll form on dust, it'll form on, we can actually do cloud seeding where we actually drop carbon dioxide pellets, dry ice pellets through the air, and in hopes that the water will condense and create clouds during a drought. So there's three main types of clouds. There's a cumulus cloud. This is the fluffy rounded pile of cotton. It indicates fair weather. It's the one that we often lay back and look at and see all types of shapes and features. It's a very fair weather cloud, so it means we're going to have a beautiful day. This is a stratus cloud. Oftentimes you can't even see the line of a stratus cloud because it completely overcasts the sky. Stratus means layers, and it produces drizzle, rain, or snow. These are cirrus clouds. These are wispy, feathery clouds. They indicate a change in weather. They're actually they're the highest clouds in our atmosphere, and they're made of ice crystals. They mean that the weather is going to change within like 24 to 48 hours. You're going to have different weather. And that's it for our atmosphere notes.